Bismillahirrahmanirrahim. In today's class, we will be implementing some of the data structures. Some of the data structures widely used are named as lists, stacks, queues, trees. Uh, so these are the more commonly used different data structure. I will be discussing them and explaining its implementation one by one. So normally in the field of data structure, a common term uses abstract data type. So what is meant by abstract data type? If you are specifying a data type, then it requires two important implementation. Uh, the first thing is that specific type will have a complete set of values, so they need to be defined, and the complete set of operations that need to be defined. So the complete set of values and the complete set of operation are represented in a common term as an abstract data type. So object-oriented programming gives us an effective and efficient way of for representation of the abstract data types in the form of classes. So you define classes in a way that a class contains all the different attributes of a specific types, and you also define the different operations that can be applied on those attributes within that class. Once the class is created, you can create objects or instances of those classes using object-oriented programming. So we will be using the same concepts that we have already learned, the object-oriented concepts for implementation of the different data structures. So our first implementation we will be focusing on implementation of lists. So first we need to clarify conceptually what are actually lists. Once we clearly understand the concept of lists, then we will work on implementing the list data structure and the type of operations that can be performed on the list. So we will jump into its implementation, defining the list data type and the different operation that can be applied on the list. So a list is actually an order sequence of 0 or more elements. So a list can, once you define a list, initially it may have 0 elements. Later on, you can add multiple elements into it. So according to standard definition, a list is an ordered sequence of 0 or more elements. Here, you should note the term ordered. The elements should be in some specific order within the lists. So if I define a list over here as A1, A2, A3 up to AN, each of these elements will have a specific type. There will be with reference to each element, there will be an element preceding it, and there will be an element succeeding it. So however, if this n is equal to 0, it means that the list is empty. So this is just basic implementation. So in conceptually, you can also visualize the list as these in the form of this row of squares, where each square represent an element in the list. And of course, as you may have multiple elements within a list, at a specific instant of time, you can focus on any one of the elements within the lists. So that focus will be represented in the form of a window in our representation, in our graphical representation for list understanding. We will be representing the current focus on a specific element using a yellow window. However, we should also know that each of these elements will have specific type. That type will be represented as element type. Element type we are using as a symbol to represent the type of each element, and the focus on some specific element will be, this focus term will be represented in the form of a window. We will write W as a window symbol representing the focus on some specific element. So this is the list implementation. Now, if we want to implement this list containing different elements, you should think of what are the different terms that you need to define. So I will quickly go through it to define what are the required different elements for the representation or definition of this list. So first, if we are going to represent or to implement a list, so here symbolically we will define L as a symbol for representation of the list. So L will be representing symbolically as a list, as each element as each list has different elements, so the element will be represented using a symbol E. Similarly, there will be different operations performed on the list, and those operations may be return some Boolean type, may return some Boolean signal that that the operation resulted in a true output or false output. So that Boolean representation will be represented using a B symbol, capital B letter. Similarly, as we discussed that we might need a window representing a focus on some specific element, so that window concept will be represented using a symbol W. So these are the different symbols. So we will use these different symbols to define the different operations that we will need, that are required within the list data type. So we will use a general representation of those operations in a form that there will be some input, there will be some output, and there will be some operation. So that general representation will be in this form. For example, first concept is for the first operation is declaration. So for the declaration, what is the declaration? It is actually initialization. For example, what you do is int n. So n is a variable declared as of type int. Now you have defined a variable n that is of integer type and that can hold an integer value. Similarly, if we have a list data type, we need an operation for declaration of a list. For example, here we declare L. So L is now a variable of type list, and that can define a list. Initially it will be empty. So the function value of declare L is an empty list. So it is something like creating an empty list. If we are more familiar with int n type of representation, then of course we can also represent it as list L. So L is an empty list declared here in this step. Now another operation is of window to be focused at the end of the list. So here the square represents a list. So the last element in the list is this one. This is the last element, and the window after the last element is representing the end of the list. End of the list doesn't contain any element, and there is a specific reason for defining this end operation or focusing on the end operation. That will all I will clarify later on when we are discussing the insertion and deletion of operation. But it's really very important to have an end L operation to focus on the end of the list. So what is the function of this end L operation? You pass a list to this end operation. In actual implementation, this end will be a function to which you will pass the list L, and it will return a window or focus at the end location of the list. So here in this list, the position after the last element is always the end of the list. Another important operation is empty L. Empty, in this operation, we need a function to which we will pass existing list that may have more than one elements. It can have any number of elements, but out of this empty operation will be that once you pass that list to this function, it will return it an empty list. An empty list is represented over here graphically in the form of a yellow empty square. It means that okay, there in this list there is no element existing. So that's the operation. So the reason for implementing this function is that if you have a list and you want to clear all the existing entries within the list, you can do it using empty operation. Similarly, there is another operation that is isEmpty. So the isEmpty operation is used to check that whether the existing list is empty or not. This is very important because we will later see that during performing different operations, you might need to check whether the list is empty or not, because the operation performed on the empty list might require different strategy than that applied on a non-empty list. So isEmpty is a very important operation, and to this operation you pass the list and it will return a Boolean value, true or false, representing that whether the passed list is empty or not. Similarly, there is an operation, we need an operation implementation of function that is first. So to this first function, you pass the list and it will return a window location of the first element in the list. So here graphically you can see that we have a row of different elements represented in the form of a square. This is actually a representation of a list. So for this operation, if you pass this list to the first function, which is performing the operation first, this function will return a window location which will be focused, or which will be representing the first element within the list. So during the implementation of the insertion, deletion, etc. operation, you will see that this is really very important operation or a function through which you can quickly jump into the first element. So if you have thousands of elements in a list and your window is somewhere within the list, it can be anywhere within the list, but if you are interested to quickly focus on the first element in the list, this function will quickly provide you an access to the first element within the list. Similarly, another operation is the next operation. The next operation simply moves the focus from the existing element to the next element. So for this operation, you need to pass the list along with the current window location, or the current location where the existing focus is, and this function will return a window to the next element. So the focus will be moved from the existing element to the next element in the list. It's I mean, it might be, it's conceptually, it might be clear. Let me explain that. Okay, if you are at the first element in the list and you pass the list and the window of the first element to this function, of course, this function will move you to the second element. If you are currently at the second location, this function will move, this operation will move you to the third location, and so on and so forth. However, similarly, if you are already at the end of the list, then there is no window location of the end of the list. So if you are at the end of the list, this function will still return the end of the list, because you cannot move from the end of the list to the next location. So in order to graphically understand these operations, so let's say our window is at the second element in the list. So if we apply this operation next, it will move us to the third element. If you are already at the third, we will be moved to the fourth, and so on and so forth. If you are at the second last, we will be moved to the last. If you are at the last, we will be moved to the end. If you are already at the end, you cannot move from into next location. That is the last location in the list where you can move. Similarly, we have an operation previous. So to this function, it's exactly, you can say, opposite to the next operation. So if you, this operation, in order to perform this operation, you need a function to which you will pass the existing list along with the current window, and it will return a window location to the previous element in the list. So the function value of previous is the window position of the previous element in the list. If you are already at the beginning of the list, so if you are already we are already at the first element in the list, the first element do not have a previous element, so from the first element you cannot move to the left side, or you can say to the previous. So for the first element, the previous is undefined. Similar is the case for the next. For the next operation, if you are already at the end of the list, you cannot move to the next if you are already at the end of the list. For the operation in next is undefined. For if you are already at the end, the operation previous is undefined if you are already at the first element in the list. So that's, if you are at the second element, the previous of the second is first. We will move on to the first. From first, you cannot move to the previous. Similarly, we have an operation, we need an operation last L. So to the last operation or function, you will pass the list, and it will return a window location of the last element in the list. As graphically seen, you can see over here, if you have a list, so the previous function, the last operation will move you to the last element in the list. Similarly, of course, one of the very important operation is the insert operation. For any data structure, the idea of the data structure is to hold the data in some specific format. So of course, you might need an insert operation to insert the data using the within the defined data structure. So whenever, so keeping in view our existing implementation of the list, if we have a list and we are inserted to insert some data into the list, then of course we need the element to be inserted into the list in which this element will be inserted, and of course you need a window location where this will be inserted. You need to specify the location where it will be inserted. So what will be the output of this operation? It will return the updated list containing the new element, and the focus or window will be on the newly inserted element within the list. So insert operation, as represented over here, you need the element, the current window location, and the list. And the new element will be inserted in the list, and the updated list will be returned. So it is represented graphically over here. Currently the list has 1 to n different elements. Our window location is, this is w minus 1. So this the location, the new element will be inserted. This E is the new element will be inserted at the wth location, and this will be the new list, and that will be returned. If we are already at the end of the list, if we are inserting an element E at a location W representing the end of the list, then we already know that the end of the list is always empty. It means that it doesn't have any element, so simply we need to insert that element at the end. So if this is a list containing a1 to an elements, and of course the end of the list is the location after an, so the new element will be inserted at after an in the list. And the window will be, keep in mind that after every insertion, the list is updated list is returned, and the window is always focused on the newly inserted element within the list. So this is a list containing different elements. If we are inserting E, an element is the location W within the list, then how it can be performed? Keeping in view that our existing window location is focused on this block, on the existing block, the insertion operation will be such that all elements, including this colored image, colored block, will be moved to the right, and so that an empty location is created, and the newly inserted location, the new element, which is represented as orange over here, will be inserted into that empty location. So you can clearly see here that before insertion, the window was focused on light green colored square block, and all the blocks to the right of this yellow window, including this light green colored box, was shifted to the right, and the new element was actually inserted to the left of this light green box. The new element is represented in orange color, and the window, after the insertion, the window is focused on the newly inserted element, and that updated list will be returned. If you are applying the insert operation in our existing window, and the window where we are interested to insert the new element is at the end of the list, you can see the end of the list is already empty. So the new orange colored square block will be automatically inserted at the end of the list without shifting any existing element within the list, and the new list will be returned. Similarly, we have the delete operation. The delete operation is such that it deletes the element at the existing window location within the list. It deletes that, and the updated list is returned. The updated list in which the element will already have been deleted will be returned. So for the delete operation, you need to pass the list and the window location from where the element will be deleted. So if you have a list containing n elements, and you have an element E at location W that you want to delete, so after applying the delete operation, the new list will have all the elements except the element which was at W location, which is deleted. Within the delete operation, if you pass a window location which is actually at the end of the list, then for the end of the list, the delete operation is not defined. Why? Because delete operation is used to delete an element, and end of the list do not contain any element, as it already do not have any elements. So it for the delete operation is actually undefined for the end of the list. So let's have a graphical representation of this delete operation. So we have a list. Our current window location is focused on the light green element. If we execute this delete operation for this current window W in the list L, that element will be deleted, and the revised list won't have that light green element within it. Similarly, we need an operation that is examine. So if you have a focus on some specific element and you want to extract that element in order to examine it, then that can be performed using the examine operation. So using the examine operation, you can extract some specific element from the list, and then you can perform different operation. You can make its copy, you can examine its different values, etc. So for examine operation, you need to pass the list in the current window location where your focus is, or the window location from where you want to extract the element, and that element will be returned. So if you are already at the end of the list and we want to examine an element at the end of the list, as already discussed, the end of the list do not have any elements, so we cannot examine an element at the end of the list. So this examine operation is actually undefined for the end of the list. So these were all different operations that we need to define for a list data structure. I will go through it quickly to summarize it. The first operation is declare L, which will return an empty list. Int L will return a window location to the end of the list, which generally is the location after the last element of the list, and it doesn't contain any element. Empty lists make the existing list empty and return a window location which do not have any element. isEmpty list actually is performed to check whether the list L is empty or not. It returns a Boolean value representing true or false. If the list is empty, it will return true. If it's not empty, if there is any element in the list, then it will return false. First list will return a window location of the first element in the list. Next of the existing position W in the list will return a window location which will be W plus 1, you can say, which will be the next location with reference to existing W location. Previous WL will move us or will return a window location to the which is actually previous to the existing W location. You can say it might be W minus 1 location. Last L will move us to the last element in the list, so it will return a window location of the last element in the list. Insert EWL will be used to insert an element E at window location W within the list L, and this function will return a revised list containing the newly inserted element. Delete WL is used to delete an element that exists at location W within the list, and it will return the updated list in which the newly inserted element is already deleted. Examine WL is used to extract an element at location W in the list, and it returns actually an element which is contained within the W location within the list. It doesn't extraction makes a copy of the existing element at the position W, and then that copied element can be used for performing different operation. So let's have an example of applying these operations on a list, and to graphically see what will be the impact of those different operations. So the first operation that we need to is to implement a list. So if we have defined an empty list, for a list actually there are two important factors. One is to define a list W and to have a focus on some to have a focus of the window W of the list. So if you define a list L, we need its window location to be focused on it. So int L actually will give us to that will focus on the empty list, will provide us a focus to the empty list. During the implementation, I will further clarify this concept as well. Once you have this window location which is focusing on this empty list, with reference to this window, we can apply these different operations. For example, if we are interested in insertion operation, as we already discussed, for the insert operation, we need an element to be inserted, this window location and list. Once you have W and L, you can insert that element within the list. So let's perform an operation insert EWL. So this orange is a new element which will be inserted into the empty window location of this list. Now let's perform another operation, that is again insertion. So now look at here. Currently, at the first step, we had a window focusing on empty list containing no elements. So when the insertion operation was performed, that new element was inserted within the existing window, empty window. Now the existing window is not focused on an empty location. It already contains an element. So if you are going to insert a new element with the focus on the existing element will be moved to the right, and the new element will be inserted to the left of the existing element. That's how it will be performed. You can see here the new element is inserted and the window is actually focused on the newly inserted element. Now let's perform another operation, that is insert operation again. But within this insert operation, we have specified the window location to be the last L. Last L means that our window existing window within the second last step will move to the orange element and the new element will be inserted. So if our window will be focused on the orange elements, so the orange element only will be moved to the right and the new element will be inserted between the orange and this gray elements. Now let's say we move our window to the end of the list. How we can do it? We already have a window, so we can perform next operation. And how it is performed to the next operation, we have passed last L. So last is itself an operation within the list which will move us to the last element in the list. Once we are at the last element at the list, the next will move us to the end of the list. So there is a concatenated operation. Two operations. Last will move us to the last in the list, and the next will move us next to the last, which is the end of the list. And this W, after performing this operation, this W will be focused on the end of the list. So if now we perform another operation, insert EWL, the new element will be inserted at the last element in the list. as the new element will be inserted at the end of the list, as the existing window is empty. Therefore, the new element will be inserted at that empty location and without moving any existing element, because the existing window is focused on an empty location and we do not need to move any existing element. So WZ, if you want to perform to move our window to the previous location, so we can perform that as well. Previous will move us to the previous window location. With reference to existing location, it will move us to the previous window location. So the window will be moved to the orange element in the list. And if you want to, we perform an operation delete over the existing window location. The existing window location is over the orange element. So if you perform delete, the orange element will be deleted. So the element at the right of the orange element will take the place of the orange element, and the window will be focused on that element which was previously to the right of the orange element. So these were the different this was all about understanding the lists data structure and the different element that it might contain, how to represent its different data members, and how to represent different member functions. So in today's lecture, we conceptually discussed all those concepts, and in the next lecture we will jump on to its implementation, keeping in view all these conceptual representation of list data members and member function. Thank you very much.